Okay, AAT, this is section 4.3, the second part, part B. We are solving rational inequalities. Okay, so this one's a little different in that it has an equals. So when we get our number line, we're going to be able to actually have some of these critical points are going to be bubbled in. So first we want to figure out what our common denominator is, and we need to get everything to one side. So we have it less than 0 or less than or equal to 0 in this case. So I'm going to go ahead and look at what the factored form of this is. This is x plus 2, x plus 3, which is nice because it's the same denominator we already have over there. And I'm going to get everything to one side. So I got x plus 1 over x plus 2. I'm going to leave a little space here. Remember, make this a plus minus, so that'll be easy to distribute later, plus negative x over x plus 3. And then I'm subtracting this fraction to the other side, so it's plus negative 7 over x plus 2, x plus 3. And it's less than or equal to 0. So when I subtracted that to the other side, it becomes negative. But I'm going to keep it as a plus minus in case I need to do any distributing. Okay, so now we need a common denominator. So what is the common denominator? I'm going to go ahead and make it one line. That's x plus 2, x plus 3. Every factor is represented. Less than or equal to 0. So I'll look at these and see what everybody needs. This one needs an x plus 3. So whatever I do to the bottom, I got to do to the top. Make sure you put parentheses if it's a binomial. So I'm going to have to multiply the x plus 1 times x plus 3. And I got to make sure I FOIL that. And then I got a plus a negative x, and this needs what? It needs an x plus 2. Got to do it to the top and the bottom. So I got negative x times x plus 2. And then this one has the common denominator, so that negative 7 can just stay negative 7. So, whew, kind of a mess, but we've got to FOIL this thing out. So x squared, the outer is 3x, the inner is 1x, so together that would make 4x. Last would be 3. Distribute our negative x, so negative x squared minus 2x, and then minus 7. All over the common denominator. Okay, so now we want to combine our like terms nicely. The x squareds are going to subtract away. And I got 4x minus 2x is 2x. And 3 minus 7 is negative 4 over x plus 2 and x plus 3. And this is less than or equal to 0. Okay, so let's look at what our critical points are to put on the number line. If we set the numerator equal to 0, we're going to add 4 and divide by 2, so x would equal 2. If we set x plus 2 equals 0, of course we're going to get x equals negative 2, and if we set x plus 3 equals 0, of course we get x equals negative 3. So this time we have 3 points to put on our number line. This number line is to try to test the positivity of this whole fraction, negative of 2x minus 4 over x plus 2, x plus 3. So I'm putting the smallest number is negative 3, then negative 2, and then positive 2. Okay, so let's look at the open and close thing here. This one's less than or equal to, so we're still looking for the negatives, but it can also be equal to 0. And a fraction equals 0 when the numerator equals 0. Let me say that again. A fraction equals 0 when the numerator equals 0. So which one of these came from the numerator? The 2 did. So this time, the numerator can equal 0, so that's going to be a solid dot on the 2. The denominators are always going to be open, which was the negative 2 and negative 3. But if you have an equal sign there, you got to make sure your numerator can equal that 0. can. So now we're going to plug in something and look at the whole fraction. So I'm going to plug in 0, which is here. If I plug in 0, I'm going to get negative 4 over 2 times a negative 3. Negative 4 on top, 2 times, a positive 3 on the bottom. So that's definitely a negative number. And so I'm going to be alternating again as long as I don't have 2 of the same factors, which I don't. I want the negative because it's less than. So I got this area and this area. Negative infinity to negative 3, open, union, closed for 2, and from negative 2 to 2. Okay, hold on, I totally messed that up. Let me do that again. Negative infinity to negative 3, open, union. Okay, this is the part I want. Open negative 2 to closed on the positive 2. There we go. I can plug in different numbers in those intervals to the original problem and check to make sure it's true. Okay, next one. This one's not too bad because it's already set greater than 0. However, we need to figure out what goes on our number line, so we need to factor the top and the bottom. So go ahead and factor the top and the bottom. Pause for a second. All right, so I got my factors, x plus 2 times x minus 1 over x plus 4 times x plus 3. Hopefully you got the same thing. So I put all those important points on the number line. Negative 2 and negative 1 come, negative 2 and positive 1 come from the numerator, negative 4 and negative 3 from the denominator. These are again all open because they are not equal to anything. Denominator is always open, numerator isn't an equal sign, so those are open as well. So I'm going to find 0. 0 is right in here. If I plug in 0, I get a negative times a positive times a positive times a positive, which is a negative. It will alternate, but you can always plug in points in a different area as long as you don't have any double factors, double roots. So we again, nope, actually this time we want the positives. We want the positives because this is greater than 0. So this area, and this area. Negative infinity to negative 4, open, union. Negative 3 to negative 2, open, union. And 1 to, I'm going to just make that an infinity. 1 to infinity. Last problem. Okay, so this one I can see does have an even root. An even factor. So this is where it wants alternate. It's already set greater than 0, so I don't have to move anything around, so that's nice. So I can go right to putting it on the number line. So on the numerator, I have negative 7 and positive 3. On the denominator, I have positive 5, but I always put a little star. If I see that it's occurring an even amount of times, it is not going to alternate around that 5. Let's look at what's open and what's closed for a second. This is equal to. So since it's equal to, anything in the numerator will make this fraction equal 0. So negative 7 is going to be a closed dot, and positive 3 is going to be closed. The 5's from the denominator, so the denominator is always open. So let's plug in 0. 0 is in this area. So if I plug in 0, I'm going to get a positive times a negative times a positive. Remember, this is squared, so this is always positive. So a positive times a negative over a positive will be a negative in this little region. This will alternate, and this will alternate. However, we will not alternate around the 5. So that will be positive, positive. You can check if I plug in my 10, I get a positive, positive, positive. If I plug in something between here, like 4, I get a positive, positive, positive. So it looks right to me. So solution, we need to look for the positives this time. So we're going negative infinity to 7. It is closed on that 7, closed dot. Union, so this area, then this area. Closed on the 3 to 5, open because we don't want to include that 5, and then we open again and do 5 to infinity. So we want to include both sides of that, but not the 5 itself. Nice job. Go practice.